In 1997, a survey of 840 households showed that 147 of them use email. Use those sample results to test the claim that more than 15% of households use email. Use a 0.05 significance level. Use this information to answer the following questions. Now, what we're doing is we're hypothesizing that the population proportion is more than 15%. More than 15% would be to the right here of this hypothesized distribution. We're hypothesizing here with this normal distribution that the population proportion is 15%. If our sample statistics landed us way over here to the right of this hypothesized population proportion of 15%, then we would conclude that the population proportion is actually greater than 15%. So we're hypothesizing that we have this distribution where the population proportion is 15%. That's our null hypothesis. If our sample statistics land us way over here to the right of that, we would reject that the population proportion is equal to 15% and conclude that the population proportion is greater than 15%. So to answer the first question, we would select the appropriate set of hypotheses here. This is what we drew out, p equal to 0.15 for the null hypothesis, and then the alternative hypothesis, p greater than 0.15. Now we need to find the test statistic. We're told in the problem that there were 840 observations and 147 successes. So n will be 840 and x will be 147. We can very easily find our test statistic using StatCrunch. So we'll push stat, proportions, one sample, with summary. Our number of successes was 147. The number of observations is 840. We'll hit next and make sure that hypothesis test is selected. We're performing a hypothesis test, and our null hypothesis was that the population proportion is 0.15. In the alternative, we had that the population proportion was greater than 0.15, so we'll select greater than and hit calculate. And now we'll get a z-statistic of 2.03 when we round to 2 decimal places. And the next question says, what is the p-value? We're supposed to round this to 4 decimal places. Well, this same box that gave us our z-statistic also gives us our p-value, 0.0212 to 4 decimal places. Now we have to draw a conclusion. Since our p-value, 0.0212, is less than alpha, we will reject the null hypothesis. Now, let's see why that is. The p-value represents the area outside of the test statistic. So, our critical z-value would be right here, and that's 1.645. Our test statistic, the z-test value turned out to be 2.03. Now that is greater than 1.645, so we landed up here, beyond our critical value. Now that critical value, which we determined from this 0.05 level of significance, or alpha, 0.05, that critical value was the point where we said, well, if we go beyond this value here, if our z-statistic, or in other words, our sample proportion, x over n, lands us beyond this point, then we're going to reject the null hypothesis. We'll reject that null hypothesis, and we will conclude that the actual population proportion is greater than 0.15. That the actual distribution looks like this with a population proportion that is greater than 0.15. So we have drawn this same conclusion in two different ways. Our test statistic is greater than the critical value. I'm going to write this out. Since z-test is greater than the z-critical value, we should reject the null hypothesis. And therefore we should conclude that the population proportion is greater than 0.15. Now, we have used the z-statistic, the test statistic, and the critical z-value to draw that conclusion. Well, using the p-value and alpha, we can draw the same conclusion. The p-value is the area in the tail here outside of the test statistic. Now, the only way that that value can be smaller than alpha is if the test statistic is greater than the critical value. So, using the p-value and alpha, we can draw this same conclusion. We can say since the p-value is less than alpha, we should reject the null hypothesis. And once again, that would lead us to the same conclusion. So let's go back to the problem and see how this conclusion is worded. What is the conclusion? There is sufficient evidence to support the claim that more than 15% of households use email, or there is not sufficient evidence to support the claim that more than 15% of households use email. Well, we did find sufficient evidence to support that claim. The next question is the conclusion valid today, and why or why not? No, the conclusion is not valid today because the population characteristics of the use of email are changing rapidly.